There is no question about it. This is a tough question. We have a regular tetrahedron with four faces, and they've got pips on them, but I'm writing the numbers. And then we are essentially rolling it by rotating an edge. It's not slipping, and we have to try and keep track of what number is on the bottom. And ultimately, what number ends up being this grey triangle. Now, here's one way to go about doing it. Let's look at the dice from the top, and at the start, it's going to look like this, and the 4 is going to be on the bottom, just like I'm indicating with my diagram. If I then roll it around this edge, and it might help, you can't obviously do this in the whole thing, but it might help to get a tetrahedral dice and just, have a go at doing this. But when you roll it around this edge, it's going to end up turning and looking like this from top down. And so we know this is going to be a 1. And what we can do, just to start with on this question, is imagine rolling it around a single vertex, so a single point. Because what now happens if we rotate it up here? Well, we can see that if I rolled it back, I'd get to 4, and if I rolled it this way, I'd get to 2. So it must be that I'm going to get 3 here when I roll it this way. And then because I'm just doing about one vertex, that vertex can never actually um, get to the top because I'm keeping it on the ground. So it must be therefore that this becomes 4 again when I keep rolling it. So I'm basically rolling it around one vertex. It's just going to go between three numbers. So here it's going to go to 1, and here it's then going to go back to 3. And this gives us a little map to help us understand here where we're not actually rolling around one vertex, it's going to be changing. So on the diagram, we can then see that we've got a 2 here, but we can continue the pattern in the same sort of way, using the symmetry of the problem. So when I had 2 here, that must mean that I have 2 up here. And then we can actually see it alternating 3, 4, 1, 2. So the next one's going to be 3, and this is going to be 1. And I can now draw on the diagram. So 4, 1, 2, this is going to be 3, and then we're going to return to the start. 4, 1, 2, 3, 4, 1 until we get to here. And now we're basically, you can see with this little shape, we've essentially got this. So if I carry on up, it's then going to be 3. And then I've got 4, 1, 3. We're going to keep following a pattern, going between 1, 2, 3, and 4 because the vertex is changing. So this is going to be 2. And then we're back to 4. And finally, we're back to 1. And that is the answer. So I'm just going to explain it one more time. We've got the dice in its original situation, and this is what I've drawn here. I then know if I roll it around one of the edges, I get to 1. But I can imagine rolling it around a single vertex. So I know it's just going to go between, when I say vertex, I mean like this. It's just going to go between 3 numbers because that vertex can never get to the top and hence allow whatever number is left to be at the top, which in this case is going to be 2. So 2 can never get to the top as we roll it around its a vertex that goes between 4 and 1 because it's a different vertex to get to this 2. So this one's got to be 3, and then we've got to get back to 4 because we recognize that we can't get to 2. Then we get this kind of pattern. We just then extended it using the ideas, but for the second hexagon, and saw that it's just horizontally going 4, 1, 2, 3, 4, 1, 2, 3, and so on. And then we can do a similar thing up here. 1, 4, 3. It's got to be 2, 1, 4. And you can see how we could extend it forever. So this would then be back to 3, and this would be back to 1. We got to this corner here, and then notice that little shape was was this one here, and that allowed me to get the 3 and then the 2, and we could carry on up here. So this must then be back to 4 and so on. Okay, I cannot explain it any better than that, I don't think. This is a hard question. I say if you're unsure, get a tetrahedral dice, play around with it, and hopefully you'll figure it out. Well done on your efforts on this question.